Intel 4004. The Intel 4004 is where it all began. Released in 1971, it was the world's first commercially available microprocessor, packing an entire CPU onto a single chip for the first time. Before this, computers used bulky separate circuits just to do basic math. The 4004 ran at just 740 kilohertz and handled only 4 bits of data at a time, originally designed for a calculator. But its real impact was proving that a whole processor could fit on one tiny piece of silicon, kickstarting the entire microprocessor industry. Intel 8008. A year later, Intel released the 8008, the first commercial 8-bit microprocessor. This doubled the data width of the 4004, allowing it to process more information per cycle. It was still slow and limited, but hobbyists and early engineers started building some of the very first personal computers around this chip, showing the world that microprocessors could power more than just calculators. Intel 8080. In 1974, the 8080 arrived and changed everything. It was faster, more powerful, and became the brain behind the Altair 8800, widely considered one of the first personal computers ever sold to the public. This chip is actually what inspired 2 young programmers named Bill Gates and Paul Allen to write software for it, leading to the creation of Microsoft. MOS 6502. Released in 1975, the 6502 was a game changer because of one thing: price. While competitors sold chips for over $100, the 6502 cost just $25. This affordability made it the heart of iconic machines like the Apple I, Apple II, Commodore 64, and the original Nintendo Entertainment System, putting computing power into millions of homes for the very first time. Intel 8086. In 1978, Intel released the 8086, a 16-bit processor that introduced the x86 architecture, the same instruction set family that still powers most computers today. This chip set the foundation that IBM would later choose for its first personal computer, permanently shaping the direction of the entire PC industry. Intel 8086. Launched in 1982, the 286 introduced protected mode, allowing the CPU to manage memory more efficiently and run multiple programs without them crashing into each other. This chip powered the IBM PC/AT and became a staple in offices and homes throughout the 1980s. Intel 8386. The 386, released in 1985, was the first 32-bit x86 processor. This meant it could handle far larger amounts of memory and run more complex operating systems. It was powerful enough to run early versions of Windows and Linux, marking a turning point where personal computers became genuinely capable machines. Intel 8486. Released in 1989, the 486 was the first x86 chip to integrate a math coprocessor directly onto the chip instead of requiring a separate one. It also introduced pipelining, letting the CPU start working on a new instruction before finishing the last one. This made everyday computing noticeably faster and smoother. Intel Pentium. In 1993, the Pentium brought superscalar architecture to consumer PCs, meaning it could execute more than one instruction per clock cycle. This chip became a household name, and Pentium was one of the first processors ever advertised directly to everyday consumers, not just engineers. AMD Athlon. In 1999, AMD's Athlon became the first x86 processor to cross 1 GHz, beating Intel to that milestone. This sparked one of the most intense rivalries in tech history, pushing both companies to innovate faster and giving consumers better performance for less money. Intel Core 2 Duo. Released in 2006, this was one of the first mainstream dual-core processors, packing 2 full processing cores on a single chip. Instead of just increasing speed, Intel found a new way to boost performance, doing multiple tasks at once, a shift that defined how CPUs would improve for the next 2 decades. Apple M1. In 2020, Apple released the M1, its first custom-built ARM-based chip for Mac computers. Unlike traditional x86 chips, the M1 combined the CPU, GPU, and memory onto one single chip, resulting in dramatically better battery life and performance. This move proved ARM-based chips could compete with and even beat decades of x86 dominance, and pushed the entire industry to rethink how CPUs should be built.